Okay, good morning, grade 7. So let's have the continuation of our discussion in Science 7. Okay, let me share my screen. Right. So last meeting, we actually discussed about the percentage composition. Okay, so the percentage composition is actually the percentage of solute, okay, in your solution, right? So I had discussed also about your NSS, or the natural saline solution. Remember? Would you still remember our last discussion? Grade 7?
Yes, sir.
Okay. The natural saline solution, which is your 0.9% sodium chloride. Okay, sodium chloride is salt, NaCl, right? Let's move forward to elements. How can we identify elements, right? When mixture is completely separated using different separation techniques, the resulting components are said to be purified. Okay, the purified components exhibit the same properties throughout and are considered as homogeneous. Am I lagging, class? Again, please turn on
No,
your
sir.
camera. Okay, all right,
Hold on, sir.
okay. Again, the purified components exhibit the same properties all throughout. Okay, meaning to say, they are what? A homogeneous in nature. Okay, these purified components are referred to as pure substance or substances. Okay, please take note of the terminology. Please get your science notebook. This will come out in your major exam. That's why. Okay, which include elements and compounds. So let's take a look at what are these elements and what are these compounds? How do they differ to each other? And what are the different characteristics of elements and compounds? Okay, if your substance exhibits the following characteristic properties, let's have one, cannot be separated to two or more substances by physical or mechanical means. We cannot, it's okay, Alex. So you need to, Gabriel, you need to take down notes in a piece of paper because again, this will come out in the major exam. Okay, again, a pure substance exhibits the following characteristic. It cannot be separated into two or more substances by physical or mechanical means. Physical or mechanical means. Okay. Second characteristic, it is a homogeneous in nature. So meaning to say, it has a uniform property all throughout. So if you're gonna get some samples, it should be the same all throughout. Okay. The third characteristic has a constant chemical composition. So whatever the composition of the sample should be the same on the source. That's the constant chemical composition. Okay. Question so far?
None, sir.
All right. So let's move forward. Aluminum, for example, is an example of a pure substance that is an element. Okay. Gold, silver, platinum, oxygen, nitrogen, and carbon are other examples of elements. Okay. So what is the difference between compound and element? When you say element, okay, you cannot actually what? You cannot actually separate them. Okay, that's the simplest form. Okay. Let's move forward. You can chemically reduce elements into simpler substances. The answer is no. Okay. Or can you chemically reduce elements into simpler substances? The answer is no. Why? Because again, elements is already in their simplest form. Okay. The answer is a big no. Operationally, an element is defined as a pure substance that cannot be chemically decomposed or chemically separated. Because again, element or an element is already in its simplest form. Okay. At room temperature and at normal atmospheric pressure, most elements are solids, while few others are either liquids or gases. Of all elements, only two are liquids at normal room temperature, your mercury and your bromine. Okay, your mercury is your only liquid metal. That's the only liquid metal. And of course, it has a property that are actually liquid. These are, or mercury and bromine are actually liquid in a room temperature or normal temperature. On the other hand, the 11 of the known elements are gases. Okay, these include oxygen, hydrogen, nitrogen, chlorine, and helium. Okay, most elements are also classified as either metal or non-metal. Okay, while the rest are referred to as metalloids. Okay, metalloids have both metallic and non-metallic properties. Okay, let's take a look at this one. Are you familiar with your periodic table of elements? Periodic table of elements, grade 7. Are you still with me? Can you hear me?
Not really sure.
Okay.
Yes. Yes, sir.
Your periodic table of element is actually a table. I memorized it before. Okay, it's okay. Your periodic table of elements are actually, it is actually a table containing a patterns of different elements. It includes different patterns of elements based on their characteristic and based on their form. Okay, characteristic in the sense that how do these elements also behave? Is this element radioactive? Is this element also in a, in a phase, a liquid phase, or in a gaseous phase, or in a metallic phase? Right? So let's move forward. The periodic table of elements is a tool that aids you in identifying physical and chemical properties. Again, we're talking about the properties of elements. It helps you remember the chemical symbols of elements, their atomic size, metallic properties, and non-metallic properties. Okay. The rows and horizontal arrangement of periodic table are called periods or series. Okay, the rows. Okay, if you have this, let me share I have my own periodic table of element here. Um let me share it to the class. Okay, hold on. Let me open this. Let's have this one. This is my periodic table, the updated one. This is the updated periodic table of elements. It is already complete before it is not actually complete. Okay. Okay, this is the um the updated periodic table of element. Again, in our discussion, it says here that the rows or horizontal arrangement in the periodic table are called periods. So periods here is this, okay? Rows, this one, okay? From potassium going to krypton, from sodium going to argon. So this is your periods, right? Okay, let's go back to the lesson. The columns or the vertical arrangements are called groups, okay? The columns. So this is your columns. This is your columns. Let me share again my periodic table. From helium going to francium, okay, columns. From beryllium going to radium. From boron going to nihonium. From carbon going to plutonium. From nitrogen going to muscovium. Muscovium. Okay, so these are your what? Horizontal arrangement or your what? Your
Columns.
groups. Yeah, the column. The group is often called family because the element in it has similar chemical properties. Okay, these are the family. Okay. Yeah, you will eventually familiarize this one. Do not memorize again, as what I am always telling you. Familiarize. Okay. So group 1A, okay, is alkali metals. Okay. Group 2A is alkaline earth metals. Okay. Group 3A is boron family. Group 4A, please take down notes. Group 4A is carbon family. Group 5A is nitrogen family. Group 6A is oxygen family. Group 7A is halogen family. And Group 8A are considered as the noble gases. Okay, because again, um, in your higher years, you will be learning about the number of electrons in their subshells. Okay, noble gases has complete electrons in their subshells. Okay, let me share again my periodic table of elements. Okay, so this is my periodic table of elements. Again, group 1A, this one is considered as alkali metals. Group 2A, this one under beryllium is considered as alkaline earth metals. Yes. Yes. Group 3A in the boron family, it is actually under boron family. So we skip this one because this is considered as representative elements. Okay. We need to have the transition elements, this one. Okay. Group 4A is what we call as carbon family because it started with carbon. Okay. Group 5A is the nitrogen family. It started with nitrogen here. Okay. Group 6A is oxygen family. So if oxygen is in here, it started with oxygen. Group 7A is called the halogen family under fluorine. Okay. And group 7A is considered as the noble gases from helium going to organism. Okay. Do you have any questions so far? No worry, I will give you a copy of this periodic table of elements. Okay, I will give you a copy because this is the updated one, the updated version of the periodic table of elements. Okay. So this is your periodic table of elements. I will give you a copy. This is in a high resolution format, so you can actually um zoom it out if in case. Okay. Metals, nonmetals, and metalloids. So examine closely the periodic table of elements. Do you notice the heavy ladder-like line that passes through between B1A? This is boron, A1. Okay, boron to aluminum, aluminum to silicon, silicon to germanium, germanium to astatine, okay, and so on. So this is actually called the Sanderson's line or Sanderson line. So let me share again my periodic table of element. I think it's in here. So the Sanderson line is actually a line that passes through boron aluminum. This one, this line. Can you see the line there in your end? This one, the ladder like.
Yes, teacher.
Yes, sure.
Can you see the ladder line? Okay. This is actually called the Sanderson's line or Sanderson line. Okay. From boron to aluminum, silicon to germanium, in between, arsenic to antimony. Okay. Tellurium to polonium. Okay. And so on. So this is the Sanderson line. Okay. It divides metals from non-metals. So with metallic properties and non-metallic properties, the elements to the left of the Sanderson line are metals, while those to the right are actually non-metals or exhibits a non-metallic property. So here, in area here, this is considered as has a metallic property. And in the area here, okay, it is actually has a non-metallic property. Okay, it is not a metal. Are you still following?
Yes, sure.
Are you still following, class? Can you hear me?
Yes, teacher.
Okay. Again, it divides metals from non-metals, or with metallic property and non-metallic property. Right? Elements adjacent to the Sanderson line are called metalloids. It has a metal and a non-metallic property. Okay? It could act as a metal and it could act as a non-metal, just like your semiconductors or semiconductors, your capacitors in your electronics. So electronic companies uses these elements as a semiconductor, okay, for what? For their equipments, for their parts, okay? Because again, it acts as a metal and at the same time, it acts as a non-metal. So it has both
Sure.
metallic and non-metallic property. Yes.
Is that in page 59? For how to do metals differ for how do metals differ from non-metals?
Yes, it
And
is.
so are the
But
other pages.
yeah, some of the information here are actually in your book. Some of the information also here are not found in your book. That's why you need to take down notes. I will not settle for a single um source because I want you to learn more, right? We will not settle for a single source. So you need to take down notes. Anyway, this is downloadable in your LMS. So most probably you can have a copy anytime. Okay? So these are the properties of metals and non-metals. Okay? Metals are usually shiny in appearance. Okay? Ductile. It can be drawn into wires, and malleable, can be hammered. Okay? While non-metals are not lustrous, they actually appear dull, non-ductile. You cannot actually wire them. Okay? And brittle as solid. You can actually break them easily with hammer. Okay? They are non-malleable. Okay? Metals are good conductors of heat and electricity with high melting point. Okay? While non-metals are poor conductors of heat and electricity and may be solid, liquid, or gas at a room temperature. So that is why your metalloid is a good material for your electronic devices or your electronic parts. Why? Because it has a property of metals and a property of non-metals. So meaning to say that it can be a conductor of electricity or heat, and at the same time, it can also be a non-conductor of heat, a poor conductor of heat and electricity. So we can actually switch them over based on the composition of your semiconductors or your parts. Okay. Metals usually solid except for mercury at room temperature, but your non-metals may be solid, liquid, or gas at room temperature. Do you have questions so far? Please take down
None.
No,
notes.
teacher. No, teacher.
Make sure to take down notes because again, some of these are not found in your book. Okay? Some of these are actually in your book. Metalloids have properties between metals and non-metals. For example, your silicon appears lustrous, okay, or dull in form, but it is not malleable or ductile. It is a poor conductor of heat and electricity compared to metal. Germanium, for example, is lustrous and brittle solid with high melting point. Silicon and germanium, arsenic, antimony, and tellurium are actually semiconductors. So they might, okay, they have the property of a metal and the property of a non-metal. So this is a good, okay, material for your electronic parts and electronic devices. Semiconductors are materials whose electrical conductivity lies in intermediate between a conductor and an insulator. Okay, semiconductors are the foundations of modern electronics, like your transistors, solar cells, and diodes. These are electronic parts. Okay, silicon is used to create most commercial semiconductors. Uses of metals and non-metals. Okay, let's take a look at their actual uses. Copper and aluminum are used for carrying electrical currents. Your wires, these are copper and aluminum. Your wires at home are actually copper and aluminum. Iron, aluminum, and copper are used to make utensils for cooking. Okay, just like your what? Your pan. Okay, it is actually iron, aluminum, or copper. Okay, chromium and nickel are actually used for electroplating. Okay, electroplating is done when you want to cover something with, like for example, if you want to cover it with silver or you want to cover it with gold. So we need electroplating. Iron, chromium, and nickel are actually used to make stainless steel. Okay, we have a lot of stainless steel condiments. We have also a lot of stainless steel equipments for cooking, correct? Silver, gold, and platinum are used in making jewelry. Your white gold is a mixture of silver and gold, okay? And also, we have also a lot of jewelry from gold, okay? Sodium compounds are used in making soap, detergent, and etc. Okay? Calcium compounds are used in making cement, bleaching powders, and plaster of Paris. Plaster of Paris is actually, it looks like a cement, okay? Some of the sculptures are actually from plaster of Paris. Some of the statues also are made up of plaster of Paris. Do you have any questions so far? Questions? Grade 6?
None.
Grade 7 rather? Okay, let's continue. Elements essential to life. Okay, we are composed of different elements also in our body. Okay, whether you like it or not, we need these elements to survive. So what are these elements? Why do we need to have these elements? Okay, these are elements that are essential to life. Okay, meaning to say, if it is essential to life, it is needed by our body to survive. Okay, their absence result to death or severe malfunction of an organism. Let's take a look at this one. These are elements. These elements are classified as number 1. Okay, bulk or structural elements. What are these elements? They are major component molecules or components of molecules in the human body. These are the building blocks of compounds that make up the organs and our muscles. Okay, these include hydrogen, carbon, nitrogen, oxygen, and sulfur. Okay, that's the major elements in our human body or in the human body. Okay, our organs and our muscles are made up of this. Okay, even our DNA. The second one is, that's oxygen counts, of course. The second one is macrominerals. Okay, macrominerals, they are nutritionally important elements that are required in amount greater than 100 microgram or milligrams rather per day. Okay, this includes sodium, potassium, magnesium, calcium, chlorine, and phosphorus. These provide essential ions in the body fluids and form the major structural component of the body. Some of these are actually in your vitamins and mineral supplements. Okay, this is to supplement the body with the need of these minerals, right? Let's have the trace elements. So the third one are actually considered as trace elements. Okay, They are elements needed by the body in a very small amount, but with large effect on the human body. Okay? These elements are involved in metabolism. Okay? Metabolism is the process by which our cells and our organs, even our tissues, performing what? A daily routine in order for us to survive. That's metabolism. The three prominent biological active trace elements are iron, zinc, and copper. Okay? Again, these are trace elements, meaning to say we need this one in a very small amount. Iron is in our blood, okay, because it is a good um a good conductor also of oxygen. We really need oxygen to survive. We are aerobic organism, meaning to say that in order for us to perform metabolic processes, we need to have oxygen in the process. Zinc and copper are actually used, okay, by our body to perform metabolic processes or these metabolic processes. Questions so far? Questions?
None, sir.
Okay, let's
None, sir.
continue. Other essential trace elements are iodine, selenium, arsenic, boron, manganese, molybdenum, vanadium, nickel, cadmium, tin, lead, fluorine, cobalt, and chromium. So we need these essential trace elements, again, in a small amount only. Okay. Some foods, including cereals, milk, bread, and margarine, are fortified with these trace elements. So no need for us to have a supplement for these trace elements. Let's move now to compounds. Do you have any question with regards to elements?
No, sir.
Questions with elements? Again, elements cannot be chemically decomposed. We cannot separate them chemically because again, they are already in the simplest form. How about compounds? Compounds can be chemically separated into their component elements. So, the proportion of element in compound is fixed. Okay? The properties of compounds are different from the properties of its component element. Okay? An example of a compound is sugar, which is composed of carbon, oxygen, and hydrogen. Okay? The chemical symbol for your sugar is C6 or carbon 6, H12 or 12 hydrogen atom, and O6 or 6 atoms of oxygen. Again, C6, that's 6 carbon molecule. H12, that's 12 molecules of hydrogen. And O6, that's 6 molecules of oxygen. C6H12O6. So that is the chemical symbol for your sugar. However, sugar exhibits properties that are different from the properties of each element. Okay? That's it. What are the other compounds? We have CO2 or carbon dioxide. Those are compounds. H2O, that's water. NaCl or sodium chloride, that is another compound. So we can actually separate them chemically. And one characteristic of a compound is that it has a chemical symbol. Okay, let's take a look at this one. Supposing you have a water mixed with salt. Can we consider that one as a compound? Grade 7?
No.
Why? Why? Krishna.
I'm not exactly sure as well.
Okay, we cannot consider them as what? A compound. Why? Remember that compounds has a chemical chemical name. What is the chemical name of the mixture of water and salt. It doesn't actually have a chemical name, but we can separate them into H2O and NaCl. Okay, so it is not considered as a compound, rather than it is considered as a mixture. It is considered as a mixture, but not a compound. Because again, it doesn't contain or it doesn't have a chemical name. Did you get my point?
Yes, true.
Okay, let's move forward. Chemists represent compounds using formulas, or it has a chemical formula based on the symbols of the elements in the compound. Okay, let's take a look at acids, bases, and salts. Let me check. Okay, acids, bases, and salts. Compounds may be classified as acids, bases, and salt, whose definitions may be operational or conceptual. So let's take a look at this one. Conceptual definitions are based on the behavior of acids and bases, as explained by different theories like Arrhenius theories and Bronsted-Lowry theory and Lewis acid-base theory. Don't worry, in your higher years, we will be discussing also these theories. Okay? An acid is a compound that exhibit the following properties. Okay, if it is acidic, it tastes sour. It reacts to some metals if it is acid. Okay, changes blue litmus paper, an indicator. Okay, we have a pH indicator, blue litmus paper, to red. Okay, reacts with base to form salts. So if you're gonna put an acid to a base, it will actually form a salt. Okay, reacts with some metals to produce hydrogen gas, just like a documentary that I actually saw. Okay, how to test a 100% gold or 0.99% or 99% gold. They tend to scrape, okay, a gold, or tend to get some of the dusts. Okay, they tend to scratch it over and create a dust out of that gold bar, and they will have a nitric acid tests. Okay, nitric acid test, it's an acid test, meaning to say that they will let the nitric acid react on that certain metal. If it is gold, then therefore there will be no reaction at all. But if it is another metal aside from gold, it will actually produce hydrogen gas. Okay, and it will what? It will dissolve in the nitric acid. Let's continue. How about base? So what will be the characteristic of a base? What are the characteristic of base? A base is a compound that exhibits the following properties or characteristic. It has a bitter and biting taste. Okay, has a slippery or soapy feeling. Changes red litmus paper into blue. Okay, it reacts acid to form salt again, and very few reacts to metal. Okay, a salt is a product of the neutralization reaction between acid and base. Okay, hydrochloric acid plus sodium chloride, okay, is equal to sodium chloride plus water. So it reacts. Okay, the HCl there, or hydrochloric acid, reacts to sodium chloride to form, or react to sodium hydrochloride to form sodium chloride and water. Okay, that's the reaction. Okay, we have the mixture of hydrochloric acid, HCl, and sodium hydrochloride will form sodium chloride plus water. These are the list of common bases and common acids. We have common acids, hydrochloric acid, referred to as muriatic. Your muriatic acid is hydrochloric acid. Are you familiar with this? Grade 7, are you
Yes.
still with me? Okay. Your muriatic acid or your acid from your stomach, the gastric juice or gastric acid, it is actually an acid found in your stomach. Sulfuric acid, which is found in fertilizers, the nitric acid, which is found in acid rain, the citric acid, which is found in lemon, lime, and your oranges. Okay, carbonic acid found from in carbonated drinks, just like your soft drinks. It was carbonic acid. Okay, that is the reason why the main reason why it is not advisable to drink soft drinks in an empty stomach because it is actually composed of carbonic acid. Okay, lactic acid. Okay, all right. How does acid rain occur? Or acid rain occur because there is a mixture of what? Okay, it is a mixture of nitrogen and your fumes. Okay, that is how acid rain is actually formed. Okay, converting nitrogen into nitric acid. Okay, let's move forward. Lactic acid, which is found in your sour milk yogurt, it has lactic acid and cottage cheese. Okay, tartaric acid found in your grapes, and acetic acid found in your vinegar. Okay, your vinegar is actually acetic acid, whether you like it or not. Next, how about the common bases? So what are these bases and what are the common use? Okay, sodium hydroxide, known as lye, used in soap making. So your soap is actually composed of a base. Calcium hydroxide, called the lime water. Okay, potassium hydroxide, known as potash, or potassium hydroxide is your tawas in vernacular. Okay, dissolved grease. Magnesium hydroxide. Okay, an antacid against it is actually antacid or anti-acid. Okay, it is used if you have hyperacidity. Okay, called the milk of magnesia. Ammonium hydroxide, this is actually a 2% solution, is used by patients who have fainted. Okay, ammonium hydroxide. Okay, um, it is sometimes called or otherwise called as the spirit of ammonia. Okay, this is to revive fainted patients. Sodium bicarbonate, this is your baking